Distillation part 1. What we're distilling is some 70% isopropyl alcohol, and I put some contaminant in there, which was just some dye that I extracted from a flower. So what we're looking right now is the temperature, and the temperature is only at 35 degrees Celsius. Here's the unit, grossly put together. Okay, the distillate should be isopropyl alcohol. So the mini still is in place. Note the tubing. Right now what we're distilling is a little isopropyl alcohol. Let's see what's going to happen. Okay, thank you. Okay, we're now approaching the boiling point of isopropyl alcohol, which is 82 degrees. And as you can see, we do see some action, a little simmering there of the solution, and we are now literally at, I don't know if you're going to be able to see that. Nope, never mind. 82 degrees. You can see some dripping. And note, here we have our first distillate coming out right on schedule. It is now 85 degrees. So I'm going to go ahead and stop this so I can lower the heat so we don't get anything but that. See you later. And yep, that's our first distillate there. Naturally, the challenge here is trying to control the temperature. We're able to, it is now down at 90. As you can see, we do have some boiling going on. The idea is that all we want to come out here is the isopropyl alcohol, which should be coming out, right? We're at 90 degrees, and we're not necessarily, we're not at 100 degrees yet. So what's boiling is not the water, right? But what's boiling? What's boiling is the isopropyl alcohol that's coming off. Again, I'll just give you that. We're currently trying to maintain at 90 degrees. We're actually doing that pretty well. Take that heat off a little. And that's how we're going to have to regulate the heat. Literally just on and off like that. And maintaining the temperature. So it's certainly not a passive experiment. Okay, ladies and gentlemen, the distillation of isopropyl alcohol. 70% with some contaminants as well. Note the distillate is clear, which is what we want. Just a quick shot of where the bulb of the thermometer is ideally placed, which is under the arm of the round bottom flask. And the reason for that is because the vapors that are coming off of the round bottom flask here, the solution is coming up, the liquid is being vaporized, and the vaporization is happening right here directly. And then so this way you're getting an accurate reading of the temperature of the solution there. Alrighty, so with that said, I just want to get one more shot of the unit in action there. The reason for this here is the water is actually having the vapors condense again at that temperature, and once they condense through this tube, they are now dripping through into the collection vessel, and this, of course, should be straight isopropyl alcohol. 100%. Obviously not, or close to it. The distillation of isopropyl alcohol. Heat source. Solution, which is 70% isopropyl alcohol with a contaminant purposely put in there of some dye. Note the positioning of the thermometer bulb. Temperature is roughly at 85 degrees. Note we are getting condensate. So the vapors come up through the round bottom flask. They then trickle down into the receiving tube, and then they are cooled by water on either side. That tube then condenses the vapor back into liquid, and that liquid is now collected in the vessel. Note the liquid is clear because that is roughly 100% isopropyl alcohol, which is being extracted from this solution of 70% isopropyl alcohol, 30% water, and about 2-3% of that contaminant, which is just simply a dye that I extracted from a flower. Okay, and there's the unit. The simple distillation. Okay, there's our pump. recycling the water.